Welcome to our presentation on the Smart India Hackathon 2024 project, where we tackle the challenge of predicting electricity demand using artificial intelligence. Our team SleepWalkers is focused on developing a model that accurately forecasts power demand, helping manage energy resources efficiently. So, let us start by understanding the challenges and that the power grid faces in Delhi. First is the complex load variation patterns. Imagine trying to predict how much electricity a city like Delhi will need at any given time. It is like forecasting how many umbrellas you'll need in a city with unpredictable weather. Similarly, power demand is constantly shifting due to changes in weather, new real estate projects, and events making it hard to anticipate and manage. Second would be the handling of the duck curve effect. This is similar to balancing a seesaw where one side represents solar energy generation and the other represents energy demand. Solar power is abundant during the day but drops by the evening, so it creates a duck shaped effect of supply and demand. This challenge is keeping the seesaw balanced, ensuring that the grid will remain stable over despite these fluctuations. Third would be the lack of explainability. Imagine driving a car without a dashboard. It would be very tough to know what your speed is or how much fuel is left. Similarly, in AI systems, operators lack clear insights into how these models makes these decisions, making it hard to trust their predictions and to act upon them. Fourth would be the monitoring of these complex power demands. Power demand is very constantly changing. It requires real time visibility to keep everything in balance and manage efficiently. Next, let's discuss our approach to these challenges. So, for complex load variation patterns, we use data driven insights. Just like predicting traffic by analyzing data from weather apps, public event calendars, and historical traffic patterns, we incorporate multiple data sources like weather, holidays, developmental projects that predict the power demand better. To handle the duck curve effect, we apply dynamic adjustments. So, by factoring in the real time solar generation fluctuations, we ensure that our model keeps updating dynamically and it prevents imbalances. For lack of explainability, we use explainable AI techniques, and it is like adding a clear dashboard to the car so that the operators can see exactly why the AI made a particular decision, and it empowers them to make well informed choices. Finally, for monitoring complex power demand, we propose an interactive dashboard. So, by gathering all the data in one place, we will allow the operators to visualize the demand situation in real time. Lastly, let's talk about the proposed solutions. So, for complex power load variations, we plan to use machine learning algorithms like CNN-LSTM and XAI that can adapt to nonlinear variables like sudden weather shifts and ensure that more accurate demands are predicted. To handle the duck curve effect, we will leverage APIs and real time weather data, just like how solar panels and smart homes adjust based on the weather forecast. The model will continuously refine its prediction, balancing the energy generation and demand. For explainability, we will provide grid operators with clear insights into the factors that are driving these predictions, much like how a pilot receives detailed feedback from the autopilot system. This transparency would ensure that the operators that will make confident and data driven decisions. For monitoring complex power demand, the dashboard will act like a control center for the grid system, allowing operators to visualize the power demand forecast and make necessary adjustments as the new data about weather comes in. Talking about the technical approach, I'll just walk through the methodology once. So first would be our step to data collection. We gather data from multiple sources, similar to collecting puzzle pieces from different boxes. Next would be data processing. This step involves cleaning and organizing data into our model so that it can use it effectively, akin to sorting these puzzle pieces by color and shape. AI model. We employ AI models like CNN for time series forecasting. These are like skilled artisans that craft the predictions with precision. Deployment. We would use Docker containers and APIs to ensure that our model is accessible and can provide real time predictions. We use user outputs. We offer real time predictions via API and visualizations through a dashboard. Monitoring. Sharp and Lime explains the predictions, and the dashboard will track the model performance. Evaluating the feasibility and the viability of this project. Accessing data through API is straightforward, so the technical feasibility is pretty clear. Operational feasibility. Real time integration ensures our model would quickly adapt to it, and it is like a live sports commentator that updates the score as the game progresses. Economic feasibility. Although the initial costs are involved, the long term savings in power management are very substantial. Talking about the potential challenges, data quality. Inconsistent data can be very problematic, similar to trying to bake with expired ingredients. We mitigate this by applying validation checks. Model complexity. Advanced AI models would require high computational power and complex tunings. We we can think of them as high performance cars that need premium fuel, right? Yes. Next would be the impacts and benefits of our project. So, who gets the benefit from it? Utility providers. So, we provide improved power management that leads to cost effective procurement and load stability for the utility providers. Data driven planning aids to better renewable energy utilization for the government and the policymakers. For consumers, it is pretty clear that more reliable demand means fewer outages and lower energy costs. Summarizing the benefits of our solution, our AI based solution not only enhances the power reliability but also supports sustainable development by integrating renewable energy sources and reducing the carbon emission. Talking about the references and the research, so we will be taking our data from the Delhi SLDC website and the Open Meteor website, and that's all. Thank you.